Hi there, everyone. I want to just show you what I'm working on with the students right now with understanding multiplication. What I'm trying to do right now is work with multiplication with whole numbers to really build a foundation with the students for understanding multiplication before we work toward grade 8 expectations of multiplying with decimals and with fractions. If the students just don't understand what's happening in multiplication, they're going to have a really hard time moving forward. So I want to peek behind the curtain and give a really good understanding to what multiplication is and what it means. I know growing up you learned of the cookie model where we make a circle and we put dots in it and we show the repeated addition with that. I want to reframe that. Cookies are fine, but I like to eat them. It does show a visualization of repeated addition, but I want to reframe this in a way of arrays or area that I think will really help us moving forward. First, I want to give a context that a lot of the students are coming to me understanding how to use the standard algorithm, and they are following the steps and they're getting the right answers, but I'm not sure that they actually understand what each of the operations means and what they're doing. So that's what I want to do. I want to look behind that curtain and show a better understanding. So when they come to me with a question like this, what is 18 times 15? These are whole numbers. The students follow the steps. Step one, you're going to multiply 8 times 5, and that's 40. Then, so they're multiplying here. Then they are carrying that 4. We don't really know why we're carrying that, but we're carrying that. And then they are multiplying 5 times 1, and then they're adding 4. So here we have a couple of different steps in here, a multiplication and an addition. Why are we doing that? Do the kids actually understand what those steps mean? But 5 times 1 is 5, add 4, that's 9. Then they know that the next steps would be to do cross multiplication this way. So 8 times, oh, no, sorry, I back that up. First, they know that they have to put a 0 here as a placeholder. Do they know why they're doing that? I don't know, but they've been taught that's the next step. Then they say 8 times 1 is 8, and 1 times 1 is 1. And then they know that they stack and they add and they get 270 as their answer. So they may be able to get to the right answer following step 1, step 2, step 3, and so on. What I want to do is reframe this so that we understand that all multiplication ever, period, end of story, is just making area. Calculating area such as area of a floor or area of a window, area that you're painting on a wall. Here I have area that I have made in this array or grid. I have 5 rows with 4 columns and I have square units in here. In here I have 20 square units. And that is basically our length times width is 5 times 4 is 20. A little hint, hint, wink, wink, nudge, nudge. If I were to take this off, these little bars right here, have you ever seen division, this sign in division like this right here? A divided by sign, 20 divided by 5 is 4. That's where that comes from. They just sort of drop off the other sides. So I just wanted to show that to show you that all multiplication is area. So we can use this as an area model to help us with multiplication without using the algorithm. And again, if you use the algorithm, that's fine, but please understand using a model what it is that you're doing. So here is our same 18 times 15 right here. And I am still using my square grid so that you can see what is happening with the problem right here. 18 times 15. Okay, but the kids are going to say, okay, I don't know how to count that. And if they were to, some of the kids, I'm not even joking, would come in and say 1, 2, 3, 4, 5, 6, and they would count all of these little squares until they figure out how many squares are in here. And what if they don't get that answer right? So we know we're going to find 270 squares in here because I just did the algorithm. At least I hope that's right. I don't know. Let's find out. So we're going to use this to help us to understand it and to use our mental math. And that's the point, is we want the kids to be able to work with this. There's other ways they can work with this as well. They can round up and take the difference and so on, but I'm showing this in an area at the moment. So I'm going to break this down into numbers that work for me. And it's still going to be 270 squares in here, but let's break this down. Instead of having 18 squares across, maybe I can make that 10 squares across. And these just happen to fit centimeters. So here's my 10 right here. And if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I do that, I haven't changed the size of my box. I just now have 10 and 8. That's still 18. You can choose to break it down further if you want. If 8 is not a number that works for you, maybe you can put another line here and make it 5 and 3. How you decompose that is what is friendly for you to work with. And that's what I like about this, is that the kids can make it work for them and their understanding. And then maybe 15 is not a number that is friendly to them too. They like maybe 10 and 5. I think those are nice round numbers to work with. So I'm going to make that 10 and 5, and I'm going to count 10 down. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 5. I might notice that I have a perfect square in here too. 10 times 10 shows us a perfect square. Okay, so now my mental math is doing exactly what the algorithm is doing, but making it friendlier to work with. So let's do 10 times 10. We know that that is 100. Interestingly enough, that matches the same as our hundreds flats with our place value blocks. I can now take a look at, if 10 is over here, then I know that 10 is over here from my properties of a rectangle. So 10 times 8 is 80. Okay. And now I'm going to look at this part. I have 5 rows of 10. So 5 times 10 is 50. And 5 times 8 is 40. And so now all I need to do is add up these parts. And there is my answer. So if I have 150, 80, and 40, that will equal, if you take the time to add that up, 270 squares inside of this box. So that is what I'm trying to show the kids of what they're doing. They can use this for a lot of different purposes. In this video, I'm not going to take you through the division of this, but I just wanted to show you that the same thing would apply in here. We would just be working backwards. I showed you before that division symbol that we all know looks like this. It would be 270 divided by 15, and then they would be looking for what that answer is up there. That symbol is just saying there's 270 squares inside that box. And if we're now finding 15 times and breaking it into parts, we can then build it down into here as well and get that answer. I did model that with the students today. It was a light bulb moment for some of them. We will spend some more time intentionally focusing on that. I won't do that right now for the purpose of this video. But what I do want to show you next is that you're not always going to have these little squares with you. But I think that by grade 8, we can understand that there's still squares in here, even if I don't show those little squares. So this is where I say this is really flexible. Right now, I could only do 18 times 15 because that's what fits on this piece of paper for the squares that I have. But if I draw an open array, I have more flexibility with what I want to work with in here. So I'm going to draw out, in this case, I'm going to keep it 18 times 15. And I'm going to try to draw it somewhat to scale here. And you notice I'm not even using a ruler. I just want to make a box that I can work with. And if I know that this is 18 and this is 15, I can break this into 9 would be about here. So I'm going to make 10 right around here. Sorry, 10. And so then I'm going to say that would be about, if I break this into thirds, it'd be 5, 5, and 5. So I'm going to say that would be right about here. So this should be 10 and 10. I tried to make it somewhat proportional, but 10 and 5. And then this is 10 and 8. Now 10 times 10 is 100. So even though you can't see the little squares, we know that really we're counting square units in here. We're grown up enough that we don't need to have those squares represented. I don't like the way I drew that. That doesn't look very clear. I want that more of a square. Okay, it could be just how I drew it. All right, but 10 times 10 is 100. 10 times 8 is 80. 10 times 5 is 50. And 5 times 8 is 40. And then we have, if we add these up, that's 180 plus 90, and that gives us 270. And there is our answer. So yes, there are more steps maybe involved in this. I might argue that there are not, but it shows a better understanding of what is happening behind the curtain of our multiplication. This also will tie into so many other areas of math that we haven't gotten into, such as when they get into high school, they're going to learn that the formula of a rectangle is length times width. And then they're going to learn that the formula of a triangle is 1/2 base times height, and it's the same thing. If I take this rectangle right here and I cut it in half, there's my formula, is 1/2 the base here and the height here, which is the same thing as length times width. So their understanding of formulas as they get older are going to matter because they connect visually with what they are understanding going on in here. And you can see how this ties into so many other areas of math than just multiplication. Here we have geometry, we have measurement. We're bringing a lot into this and number operations too. So these are really good foundations. I want the kids to be practicing this, at least with multiplication. Take 2-digit numbers at home and toss them at the kids. Give them a whiteboard or a piece of paper. See if they can decompose this, figure out the parts, and add up the parts. That is a really great way to build their understanding with this. They can break it up into as many parts or as few parts as possible. I may caution that if you break this up too much, then it's adding a lot of little parts, and that's a lot more steps. But this is a really great way. As we practice, we're going to get into division, long division, bigger numbers using these strategies, and then we'll get into decimal numbers and fractions and tying it all together in other areas. But that might give you a good foundation to begin with to understand the behind the scenes to what is happening in that standard algorithm right here. Okay, thanks.